Right. Hello, Shingor. So the assert happens in this line. Meaning that we're trying to insert the script set layout binding for the second time. Which happens from restore the script set layouts. Hello, Adarsha. So this restore is the result of, well, the fact that we see that this is already compiled. And then the assert happens because it is compiled by the same vectory pipeline. Because that is the shader. If we scroll up in the debug output, then we see that that shader is being restored here. I might not always print that name. Here it is cached. I'll say it's hard to see for sure, but I think that this is the pipeline factory here that was not involved, because the same thread that says that tries to cache it here, that would be thread +0, is then continuing printing stuff, cached, entering unlock, mutex released, falling through 2, and then getting back into a pipeline factory member function, where that this pointer then is printed. So yeah, not super clear. Let's say that this is a task. So this is a task that is running. That would be the characteristic range. I guess I should remember both. So this is the characteristic range, and this is the factory. So now this function here is called from, well, I don't know, after that entering SPV cache is being created, is being called. Yeah, it says that it's compiling. It's the same threeple 0. Compile. Preprocess 2, yeah, so it's preprocessing that shader that is highlighted here, and then the rest follows, I guess. And this comes from the fact that we call build shader on the same thing. Log and task mutex entering build shaders. Characteristic range. So it's just the characteristic range task that is running. Even the same one, or no? Well, it should be, I think. Might as well. No highlights for. Oh wait, here's one more highlight as well. Preprocess 1, yeah. So again, that let's highlight the this pointer of the characteristic range task. Yeah, I don't think it really matters to find this beginning of this. Might as well go here, start here. Here's a signal. So this task gets a signal do fill, and that is for fill index 0, which is printed here. Okay, the signal. I don't know what this was. 9060. Oh, that is sorry. That is the Python factory. So the characteristic range sends the signal do. Sorry, no. We get the signal do fill on the characteristic range, and the factory is waiting then for that to be finished. For all characteristics to be filled, actually. So So then this fill signal results in executing the fill or terminate on the characteristic range. Which then runs fragment pipeline characteristic range fill with fill index of 0. That would be the first one. That then calls add shader. So I need a value here. What is add shader index? Ridiculous. Yeah, that didn't help much. Maybe I should run it again then. Let's see how many fill index zeros I have. Oh, does this even run in the debugger? Let's. Quit. How many debuggers do I have open? Here's an indication for the pipeline factory already, this pointer. Restore. Characteristic range. So this would be the characteristic range. See, characteristic range is that. The other one is in the pipeline factory. We're going to highlight that one. I think I want to scroll up very far. There's the fill index 0. Could be it. Yeah, I think that's all right. Got at the same point here. Now you get the do fill signal. And then that's a factory again. So the factory is now waiting for all the characteristics to be filled, and the characteristic range is running fill or terminate. No, I have no clue what this is. That should be a task. This is a characteristic range. I think it's a different characteristic range then, so they can ignore this one. But the purpose doesn't need a purpose. To make it easier to write a Vulkan application, that's the purpose, I guess. Characteristic range fill or terminate is run on the characteristic range task. Therefore, we run the fragment pipeline characteristic range fill state for fill index 0. And now we see finally the value. So now we're back where I was before. We add shader with the shader index number 2. Apparently then we are done. There's only one characteristic, so the characteristics are have now been filled. Although again, no clue what this pointer is. Oh wait, that is our pipeline factory. Yep. So the pipeline factory receives the characteristics filled signal. And then it does do preprocess. No, wait, the characteristic is waiting for do preprocess signal. Then it gets the do preprocess signal. So it runs preprocess. Which causes us to preprocess squares.frag1.glsl. So I would say that this then is the one that belongs to index number 2 that we just added. Add that here as well, I think. Follow the same thread, so thread pool 02. MX position not found, texture index is found, so it's just pre-processing the stuff. Let's go back to what the resources were that it found. I see two, right? Push constant and texture index. I can see that here. So we have combined image sampler top, push constant and texture index, and combined image sampler bottom one. So three things. But the push constant is not part of a descriptor set, so that does not have nothing to do with the problem, which is about descriptor set layouts. So we can concentrate on the combined image sampler top and bottom one. And we see that it finds, well, the push constant is found, and top is found. I wish I saw bottom one was found, to be honest, to keep life simple. Yeah, bottom one is found. But even before we find bottom one, I see that the binding is assigned. The binding that is assigned to combined image sample top is 0. And the binding assigned for bottom one is also 0. So it's probably a different descriptor set. And then we have in the bindings top with a binding of 0 for the fragment shader and top. And we have also, I hope, bottom one in here somewhere. On the top. So all the tops. Yep, I don't see a bottom one here. No. I guess it's just printing this for some descriptor set, so we get just to see one of them, just the one that has binding 0. So there we get pipeline factory push back descriptor set layout binding, and then it pushes back binding 0 for a combined image sample for the fragment shader. So I guess that makes sense. Then I guess this is a descriptor set. Not sure, but I want to know what else is. Yeah, and you see, and then the other one. That's for bottom one. So bottom one also binding number 0, also fragment. I have no clue why. Let's see, where is that? It is directly after the name. It says the set index hint is number 1. So we scroll up, binding contains here. Yeah, so this is set index number 0, and this and bottom 1 goes into set index number 1 apparently. It's 2 different set indexes. So yeah, that's that one. They are being added with different IDs. This is just extra debugging specifically for this bug. I have an ID 10,002 and 10,003 that's being used for these two. Factory. Realize the script set layouts. So here you see that the total amount of descriptor set layouts that we have is this one with a binding 0 for the combined image sampler, for fragment with ID 10,002, for set index hint number 0, and that one, which is also binding 0. I mean, also combined image sampler. Also for the fragment shader, but with a different ID, 10,003, and a different set index hint. So now we have both in the sorted descriptor set layouts vector. Yeah, both match the same layout thing, so it says that it was already in the cache even. So it said here found in cache, descriptor set layout that handle, which is corresponds to binding 0 for a combined image sampler for a fragment shader. And well, that's both of them. So the other one says the same thing, also found in cache, and it's the exact same handle for the same things. Now we are done, so we call CharacteristicRange preprocessed, which sends a signal, characteristics preprocessed to the pipeline factory. And the characteristic task is waiting now for a compile signal. Hi Tobias, I'm unfortunately still alone. I don't think anyone even managed to compile it yet, because every time people say I'm going to compile and they disappear. I have a documentation website where people can now add comments, but it's only a few days old or a week old. But no comments for the chapter that explains how to compile it. But it might seem simple to you, but I have to concentrate. Let's see, signal, there was a pipeline factory, receives the signal preprocessed, and the characteristic is going to wait for the compile signal. And then we just skip the other thread that's doing stuff. I think I want to go thread pool 2, it switches color. If this thread switches color, it just the same thread that runs a different task from the thread pool, so it's not really interesting anymore then. I better look at the highlight here. We receive a signal now on this thread. Do compile. And then we're going to wait until we are compiled. Okay, so this will now start running CharacteristicRange compile. Falling through to build shaders. I'm going to log on the task mutex. Entering add shader stage build shader. There's our shader. And that shader therefore contains the top and the bottom one thing still, but now we are really going to compile it. Shader resource declaration context generate. So this is still the template code. So now it's going to generate the declarations for these things. I don't think that's very special. It's just doing it. So do I have to look at this? Well, let's look at it. Generating declaration, running over M bindings that has the contents. Blah blah blah. Shader resource binding pair is that. Entering set index hint map convert 0, entering shader declaration contact generate, generating another declaration. Yeah. Stuffs. Until we get here, now we have the declarations. So this was added to the top, and these are the declarations that were added. And the rest was still there. And our strings are now replaced with yeah, whatever the declaration was added. So this is now the push constant, and this is the top, and this is the bottom one. So you can see how it replaced it. So replace that string with that. So now we have real GLSL code that we can compile. It's going to take a while. See, this is thread pool 00. Oh, that looks like it is immediately done. This is surprising me. Normally it takes a very long time to compile stuff, so compiling, and then normally you have to like pages of debug output before it is done. I don't know. Seems to be done here already. Yeah, no, seems to be done. I don't know. So now we are caching the results. Lucas, you seem to have no idea what you're talking about. I'm reading debug output. What the hell does what does that have to do with an IDE? Any IDE? Tweede resource declaration context, cache descriptor set layouts. Okay, it shows the name and the template code again, so we can recognize it. And it informs us that now it is cached. You can see this is binding 0, fragment shader, combined image sampler, and for set index number 0. So expect the same thing for set index number 1, I guess. Yeah, well, I'm not coding, I'm reading debug output. Created object, that's another thread. It's kind of strange, this. This seems to be the exact same thing as before, and it should be, except that it's for a different descriptor set, which you can see in the next line. So this was about 0 and this is about 1. But you would say that if it says cache descriptor set layouts, then we already should see the descriptor set its index itself somewhere. So I don't see it. except actually it's mentioning 0 here. Oh, okay. Here we have descriptor set layouts is empty, and here we have descriptor set layouts is already filled with what we just added, which is for set index 0. And now we are going to add to that what we have, I guess, for the new set index. So now it adds this one. So you can see a descriptor set layout, m descriptor type. That's the same as this. And then m binding 0, here also m binding 0, m state flags, everything is the same. Except the last one, m cache set index is 0, and here m cache set index is 1. Okay, now we're done with compiling, falling through to CharacteristicRange compiled. We call that we have compiled, and we start waiting on the next fill signal. Sorry, which one thread was that? Thread pool 0 still. So ignore all the other threads. Thread pool 0 again, but it has a different color. So yeah, I should probably look at my highlight then. Here we get the do fill signal. So now we are done, I guess. So we have preprocessed it, compiled it, cached it, everything. And now we get a new do fill signal. That would be fill index 1. So now we are running characteristic fill or terminate. Well, it's the base class. So we are running fragment pipeline characteristic range fill with fill index 1. We have filled signal characteristic filled. Wait for do preprocess. Signal do preprocess. Wait for preprocessed. Run preprocess. And train preprocess shaders and realize the descriptor set layouts again. Entering add shader stage, restore descriptor set layouts. So it sees that it is already compiled, that one. Therefore, now it says, well, let's restore it. Now that's weird. That is downright weird. Why does this happen? I did not encounter another add shader. I did. So it seems that we did not call that again. So this thing here does call add shader 2 once, and then for the second fill index it starts processing the previously added shader again. I think that's what is happening, and I want to understand that now from the side of the C++ code. Exactly. So it only adds it for fill index number 0 and not for fill index number 1, as it should, I think. Interestingly enough, I added a new assert. I think that if I remove this, my new assert should fire. I want to just test that. Yeah, and it does. That's good. But this even said don't add the same shader index twice. That's interesting enough, because so that gets triggered on shaders that need compiling. This is my new assert. I'd rather seen that it would have assert here. So apparently what goes wrong, is that shaders that need compiling, it just isn't cleared or anything. It's for fill index 0, it adds shader to this vector here, and then it stays there. While I would say it doesn't need compiling, or you just have a wrong name here. It's not a these are not shaders that need compiling. These are shaders that are needed for in the pipeline, or not. I think there's a dual meaning here. You have two meanings. Well, I have shaders that we need compiled, and then we need shaders of, if you want to use a shader, you have to compile it. So we have shaders addressed by some index, and then if we want to use it for current pipeline, then it needs to be compiled, but it would be completely okay if it was compiled by someone else or somewhere in the past. At least, you know, it should be compiled at least once. So I would more call that let's say, required shaders or something like that. Shaders that you want to have in the pipeline. You want to use them in the pipeline. And then you have shaders that just are not compiled yet. So they still need compiling. I thought that the meaning of this thing was purely that they still need to be compiled. But maybe something went wrong and I abused this thing for two purposes. Not just for shaders that need compiling, but also as a list of shaders period that we want to add to the pipeline. It's a really nice song, but I cannot stand vocals at the moment. Okay. I need to figure out how this thing is used. Okay, this music sucks. Could do no music. I can also not stand no music. I need music. Quick. Sorry, but then we have to go again here. And I'll play music myself. It's a bit loud. Can't hear myself. Yeah, now we have music, so here I loop over it. Here we add stuff. And here I loop over it. And here I loop over it. And here I seem to loop over it. Wait, there's a comment. Aha. Okay, so formulated this way, these are not shaders that need compiling, these are shaders that are needed for the current pipeline, for the next pipeline. That's what this comment says. And then this comment says the opposite. Shaders that need pre-processing and building. So yeah, there's a dual meaning for this vector. Oops. That's a problem. I guess we'll just have to make two vectors then. One with or yeah. Or I should just check if they have already been compiled or not. Every time again. Difficult decision. Okay, let's look more closely to the code that is using this. So this loop, for example. This is just a debug loop. It tries to prevent that you add something twice. Not very interesting. Yeah, I was really thinking. This function exists, but it's never used. It should be called from user code. Aha. Okay, yeah. Good one. So that then totally gives clear meaning, I think, to this vector. It's really the shaders that you want to use for the next pipeline. God, why am I even distracted by this music? Extremely distracted. Everything. It's I think it's just a matter of having a wrong name. Names are so important. If you give a wrong name, then you can just completely misunderstand the whole code and things can go wrong. I want to rename this shaders that need compiling into what? Yeah, another meaning. Okay, anyway, before I rename it, I have to look at all the code, I think. This is this allows the user to replace a previously add shader, replace it with something else. It's exclusively talking about the index. no music. How about that? VI. Pre-process shaders and realize the script set layouts. So yeah, you could say that if I rename this thing to shaders that, well, are needed for the next pipeline, then I can simply check in the cache if they are already compiled or not. And then continue if they are, and otherwise compile them. Why not? If this flag is set correctly, and I don't see a good reason why I wouldn't. It goes through the application, get shader info, gives me a, takes a write lock on the DQ and then return something. Can turn a reference because shader infos underscore W list is a DQ list. DQ. Yeah, it's just a DQ. It's a DQ for which references are not invalidated by inserting more elements at the end. That then says that, well, it says, it doesn't even, it's not required, I think, but it says that we would only add stuff here. Well, definitely have to do that. New shader index only incremented. Guess this works. So let's check what the thread safety of this is compiled thing. It is an atomic. load and acquire here. Store set when set compile is being called. Set compiled. Set an atomic boolean for the sake of optimizing pre-processing away. We can't use shader module for that because preprocess 1 is called outside of the critical area of shader info cache task mutex. Such as a race condition, but it will at most lead to an unnecessary preprocess of the same shader without compiling it afterwards. What is the guarantee here that only one thread does this? Really should have some mutex locked here at this point, but which one? Or do we? I think it's the fact that at shader stage is a base class of a task and tasks are single threaded, kind of. So, but yeah, this is about a cache which is passed, not that this object. Yeah, I'm going to assume that the cache is locked at this point. Apparently we have a shader info cache task mutex. Although it kind of depends, of course, on what is happening before this is being called. Try to find that back. Oops. Yeah, we have a lock. Okay, so we have a lock on the shader info cache, which is being passed to build shader. And therefore, there's only one thread at a time that runs this. And it's that same thread that tests and sets mShader module. So the threads enter here one by one. And if it is not set, it sets it. And otherwise it doesn't do anything. Well, it just does that. After it compiled, cached everything, we set a flag to stop, to optimize, as it says, optimize here. That loop that we saw, then we see that flag is set, and we know that everything is completely done. Otherwise, we might still call preprocess 1, but then we enter here at some point, I think. We would preprocess and then call build shader probably, and then we get here and then we say, oh, okay, let's do nothing. Then we just preprocess for nothing. Yeah, and that means that we also should not do caching, but the caching is done here. So that works out. Just that we did preprocessing, we didn't use it. So that looks good. That looks good. So this is just an optimizing flag, as it were. Okay. Yeah, so if the flag is not set, then we call preprocess 1. But then later on we might or might not use it. So I think I just have to concentrate on when it is set, the flag. And then apparently there is a problem with caching here, restoring rather. I'm restoring it, assuming that, you know, we're not the same pipeline characteristic task, I think, that already has this data. That is the bug then. Okay, so continue looking at that. The code where that is being used. I think the last one was this one that I looked at. Now let's look at that one. Build shaders. Well, it's kind of some kind of asynchronous loop, where the loop variable is part of an object. So yeah, does that need compiling? I assume that something new can have been added in between these calls. So size might be larger than the previous time. Hi Lance, you mean you're happy that I'm back at doing C++? Yeah, but just because I ran into a bug. I still have to do a lot of documentation. Before I really can go back to coding. This is need compiling. Index unequal size of the thing. Then we're not done yet. Yeah, well, I might be writing documentation about C++, but I'm kind of done with the CSS and the JavaScript and the HTML. Yeah, that's more or less finished. So if I work now on documentation, I'll be writing documentation about C++ code or about Linux view or not. I'm not working on a website generator or something like that. No, this looks like Chinese to me. No, what's going on here. Okay, there's just some magic, I guess, in order to get the task mutex. This is asynchronous stuff that runs over a possibly growing vector, sorry, DQ, I think it was, and then get the lock on the application-wide cache. shader info cache. And then if we get that, we call build shader. So we call build shader on everything. In the M shaders that need compiling, yeah. Yeah, here we get the shader index here from that DQ. So here it really has the meaning shaders that need compiling. Yeah. Build shader. Yeah, or not. Because build shader is not even doing, it's not even building shaders. It's only building it the first time. Still using a cache here. I have my naming a bit wrong. Okay, so I have been using the word realize to either get something from a cache or create it if it is not found in the cache. Pretty sure that that's exactly what this thing is doing here. So I think that I need to get my naming right. So I think that I'm going to rename build shader to realize shader to indicate that it might not build it, but get it from a cache. And well, the exact cache that we just passed here. That cache. Doesn't even look in the cache here. So cache is already being passed. It's kind of silly construction. I'm not happy with it. So yeah. Okay, we still have to do this. So probably should not change the structure. Building it's not what it's doing anyway. It's more like this, filling M shader state to create infos. Let's call that realize. I think I'm happy with that. Build shader, okay. GPS build shader. Um, I'm not convinced. Oh, these build shaders are just calling themselves, as it were, so that's probably the same thing. Yeah, everything add shader stage is the same thing, of course. I have a batch for add shader state. There's a comment about build shader. Who cares? More build shaders. IMQ is calling build shader. Looks like I can just rename all of them, right? But I'm not convinced. No, there's also build shaders here. I should probably do this manually, one by one. What's this function doing anyway? Yeah, this is calling a realized shader. So I think I should rename this actually as well to realize shaders then. It's not necessarily building it. It's just calling realize shader. on all of them. Light shaders, build shaders. Holy poly lots. Start build shaders is another one. Build shaders, but it's a build shaders. Now calling realize shaders. You know, really, I'm going to replace everything, I think. So undo, redo, who cares? So do GPS with an X. And then highlight build shaders. And then see if we want to replace everything. I think it's all the same thing, right? Pretty much. So I can do CD in place, execute, ups in place, execute, substitute, build shaders with realize shaders everywhere in all these files. Yeah. Bridge.h, CharacteristicRange.h, add shader stage. Then what to do with these? They're just the required shaders. Added shaders. Current shaders. Needed shaders. Considering that you do, as a user, do add shader or replace shader, I guess I should call them added shaders. Yeah. So that was recently added. I'm not sure I even need this anymore, so probably should just remove this. Not updating it or anything. Maybe I'll need a new vector, but for now I'm just going to call this added shaders. Field by calls to compile. I don't think so. Builder shaders. I think that was build shaders, which is now called realize shaders. Shaders that need compiling index. Yeah, see. And I'm going to rename this to added shaders. Whoops. No. Added shaders. So yeah, she's just added shaders index. Right. I still have this commented out, so I still get my assert there. Hey, Post Bunny. What looks beautiful? It's cold here. No, I don't have enough clothes on. Right, so yeah, let me put something on. Cool. Yeah, and I should eat dinner as well, right? Suppose when you tell me to eat. I think I'm gonna cook. Oh, I've been so lazy that I did not go shopping. So I was like, yeah, well, I don't go shopping. I'll just eat vegetables and no meat. But yeah, laziness, you know. It's also not good. And the shops are still open, so I could still go. Probably should do that. I think I'm gonna do that. Holy 12 viewers. I didn't look at that. I covered the number of viewers. Well, yeah. I was like, well, if I have 4 or less viewers, I'll just go shopping right away. I have 12 viewers. But I still have to eat. 12 viewers or not. Let's make a plan. I just have to go to the shop, I think, and then cook, and yeah, you know. So people who are very disappointed now, well, imagine me continuing like this for another hour, I guess. And then I run it and it works. That's the only thing you're missing. It's really, it's going to be more of the same. And then suddenly it works. Unless, of course, you can follow it. Then you will see me fix that. Trying to remember what that loop is. I have no idea. I can find the back like this. Assert. Where are we now? Push back, restore. Restore is called from here. So that's the thing that I wanted to see. So yeah, I'll rename this now. This is just added shaders, so the shaders that we want in the next pipeline, and then when it is already compiled, I'm still trying to restore something. Yeah. So I cached it, and now I try to uncache it. I think that restores maybe not the right word. What's the opposite of caching? I would say retrieve, but that's maybe the answer, and I don't want to give it a hint. So I use the ugly word get. If it's gonna tell me to use retrieve, then that's definitely the word, right? Okay. So when that thread gets the data from the cache, I currently use the word restore, but I don't think that is the best word. What is a good word that I could use instead? Retrieve. Yes, I knew it. It's only when I was typing it I just came up in my mind. So I'll rename this to retrieve, maybe, and that, yeah, no, maybe I just said I would do it. Retrieve the script set layouts, okay. Yeah, better than restore, I think. Yeah, retrieve is the word. So the idea is that one pipeline factory caches it and then another pipeline factory retrieves the data. But now it happens that the same pipeline factory is caching it and later retrieves it. And then we get a collision because it just tries to retrieve something that it already has. Was that data that it was caching in the first place. So I have to figure out a way to not do that, and then we'll be fine, and then it will work.